Volumes. Please open scene 01 cookie.c4d. With Cinema 4D Release 20, your modeling workflow gets enhanced with voxel-based tools based on the open source library OpenVDB. Other than building objects with points and polygons, you can now model objects with voxels, meaning three-dimensional pixels defining a specific volume in space at a specific resolution. In Release 20, the use of OpenVDB tools is focused on modeling. Other volumetric VDB stuff, such as explosions or clouds, can be loaded in Cinema 4D Release 20, but cannot be rendered with the native render engines. To get a first idea of the possibilities of R20 volumes, think of something like voxel-based modeling with Boolean workflow. Objects such as primitives, polygon objects, splines, particle emitters, etc. can be subordinated to a volume builder object and can interact with each other by Boolean operators. While this description might be technically incomplete, it might give you a good first impression of what can be done. To turn your voxels into polygons that can be rendered or deformed, etc., you have to place your volume builder inside a volume measure object, which also can be created from the main menu, Volume. Volume Builder. Please open scene 01 cookie.c4d. To get started, go to the main menu, Volumes, and choose Volume Builder. Then drag and drop some object as children of the Volume Builder. Alternatively, you can drag and drop the objects in the Volume Builder's object list. You immediately get a voxel-based, meaning volumetric, representation of your objects. Volume Builder supports all types of Cinema 4D objects. With the Volume Builder's parameter voxel size, you can define the resolution of the volumetric grid. Let's have a look at the objects list. When clicking on your Volume Builder, you will see objects placed inside an objects list with specific layer modes, defining if the Boolean operation should be union, subtract, or intersect. Let's have an in-depth look at our example scene 01 cookie.c4d. In this fully shaded and lit example, some spline objects and cylinder primitives are arranged as childs of the volume builder and mimic some kind of cookie. All objects are set to union mode. In union mode, it practically doesn't matter in which order you arrange your layers in the list. In subtract or intersect mode, you will get different results depending on the order of your layers. Above all objects, there's a smooth layer applied, coming from main menu, volumes, smooth filter, smoothing out all underlying structures. Its parameters look typical for a mathematical blur process. Strength, filter types, maybe Gaussian, median, Laplacian workflow, distance, and iterations. Additionally, there are options for accuracy. This smooth layer is associated with a spherical field with inverted remapping, creating a smoothing effect towards the edges of the cookie. On top, there's a reshape layer with a filter type set to delayed erode. With a positive offset, this layer is delaying the whole mesh a bit. The reshape layer is also associated to a random field, so the mesh dilation has a random noise-driven amount. Please note, a reshape layer has different filter types depending on the filter type of the volume builder. This is also indicated by a different icon for the reshape layer in the volume builder's object list. Let's have a look at the different volume types of the volume builder. With the drop-down menu Volume Type, you can define how voxels are placed. Signed Distance Field, SDF. Voxels are created on the inside and outside of a polygonal geometry with a definable range. This range is specified by interior voxel range and exterior voxel range. Spline voxel range and particle voxel range do a similar calculation for splines and particles. Please note, as SDF is only creating a layer of voxels around the polygonal surface of the object, make sure to have enough volume, meaning voxels, to work with by eventually increasing the interior voxel range. With the volume type set to SDF, the reshape layer filter types are delayed erode for expanding or contracting the mesh, and close open for closing holes or connecting objects close to another. The next volume type is fog. Voxels are created in the complete volume of a closed polygonal object. It is also the type of volume natively used when you drag a random field in a volume builder. With the volume type set to fog, the reshape layer filters are offset, adding or subtracting values from each voxel, range map, converting a voxel value range into another value range linearly, and curve, converting a voxel value range into another value range with a curve. Let's have a look at parameters for object list layers. Depending on the type of objects in the volume builder's object list, you get different types of parameters. Here are some examples. If you have a spline there, then you get radius and density, meaning you can define the area where voxels are generated around the spline, and you can define their density. If you have polygonal or parametric objects there, you get the parameters use mesh points, meaning voxels are generated around points, and optimize and close holes, meaning objects that are not closed will be treated as closed. If you have a sphere in your object list, then the option perfect primitive is added, as with parametrical spheres in the object manager. These parameters also vary depending on the type of volume you're using in the volume builder, SDF or fog. With fog, two more parameters appear. Inside voxel falloff can control the depth to the inside where voxels are created, and maximum voxel falloff will calculate this falloff depending on the volume of the object. Let's have a look at the volume measure. The volume builder with all its objects in its list is just a voxel representation. To get an object you can work with, render it, deform it, etc., you have to create a volume measure object from main menu, volumes, volume measure, and subordinate the volume builder. This creates a nice quad-based polygon mesh. There are two parameters available. Voxel range threshold allows you to expand and contract the resulting mesh. Adaptive lowers the polygon count in an adaptive process. This means it's sustaining polygons in more complex areas while decreasing the polygon count in more simple areas. Usually 10% are a good value to clean up your mesh reasonably. Fields as a source for the volume builder. Please open scene 02 volume noise field.c4d. Fields coming with R20 can also be used as a source for the volume builder, meaning you can drag them into the volume builder's object list. Let's have a look at an example here in our scene. In this scene, the only source for the volume builder is a random field set to a Luca noise. That's all. The noise can be adjusted and animated just as you know it from Cinema 4D noises, and is already creating an interesting structure. If a field is a source for a volume, you have to choose a spatial area where voxels are created. For this, you have two choices. First, box. That means voxels will be generated in an adjustable box area. Second, objects. Voxels will be generated in the voxel grid of an object arranged above the field in the volume builder's object list. There are two more things left. First, volume mesh command. Beside the use for VDB related volumes, there's also a volume mesh command available under main menu, volumes. This is basically a retopology for messed up meshes, e.g. when you sculpted something and you're not satisfied with a mesh flow. Last but not least, volume loader. With this dialog you can load external volumes based on VDB technology. Note, volumetric effects such as smoke, explosion, etc. can be loaded but cannot be rendered with these effects. Let's have a look at another example scene. please open up scene 03 volume field.c4d. In this example, a group field object combines a random field with a linear field. In the group fields fields list, you will see that the random field is overlaying the linear field. With this configuration, the random field does only have an effect when the linear field comes into the place. This scene is a good example that a sufficient interior voxel range, in this case set to 24, of the volume type SDF is needed to ensure that the field's effect is not only showing up in a thin area around the polygonal surface of the dragon.